Hi, can everyone hear me? Good? Awesome. Good morning and thanks for coming out. My name is Isha Pandarkar and I'm a technical program manager on the AWS Application Security or AppSec team. And today I'll be going through how my team went about building a security knowledge management platform for AWS on AWS. So during this session, we'll cover how to effectively distribute policies and implementation best practices within a large organization in a scalable way by going through the AWS application security team's journey to get there. We'll walk through an overview of the AWS Application Security Review Program and how we built a tool to help scale this program. We'll dive into our journey of building a simple security content management tool using AWS to manage content and complete threat modeling at scale for AWS products and services. We'll also look at how this guidance can not only be consumed by humans, but also by automation to identify security threats to a system. It's important to note that this platform is not necessarily limited to security content, but can also be expanded to include general software development or engineering best practices. You can even go beyond the tech space into things like financial guidance. But for the purposes of this talk, I'll focus on specifically how the AWS AppSec team identified a need for security knowledge distribution at scale and built a mechanism to disperse this knowledge in a scalable way across AWS. AWS holds a consistently high security bar across the organization that drives our engineering and innovation in building secure products. You, our customers, expect a secure service that protects your data, and we are your advocates here. AWS Security, in collaboration with the product teams that are building services, owns defining the guidance that enables us to uphold that high bar. More specifically, the AWS AppSec team reviews the design and architecture, as well as performs penetration testing for new services and features launched by AWS. We partner with the product teams that are building these services to engineer them in a secure way and keep your data safe. One of the ways we uphold that high security bar for our customers is through our security review program. We work with product teams to start the security discussion early so that we can collaboratively come up with a secure design. By reviewing the design earlier in the product lifecycle, we can identify and mitigate issues before they can even be introduced. Basically, we embed security at every stage of the software and software development lifecycle. We're not the party of saying no or policing what our product teams are building. Rather, our job is to figure out how to do the awesome things our product teams want to build for you and figure out how to build them in a secure way. We also work with product teams on their roadmaps, especially around security features and functionality for our customers. In addition to these design discussions, we collaborate with our partner teams to build and run automated test cases at different stages of the product lifecycle, such as security integration and unit test cases for deployment pipelines, as well as static code analyzers throughout the implementation phase. Post-launch, we have production scanning for anything suspicious or out of the ordinary. So it's no secret that AWS is growing quickly and launching new features and services fast to enable our customers to do more. In 2018, AWS launched over 1,900 significant features and services. So given this growth rate, we wanted to enable our builders to innovate even faster by equipping them with the right security guidance for our infrastructure, every stage of the way. So we needed a quick and efficient way to disperse security knowledge within AWS at the scale of AWS. So who here uses threat modeling or has heard of threat modeling? Okay, that's great to see, lots of hands. So threat modeling is a critical step in architecting a secure design. And for the AWS AppSec team, threat modeling is our bread and butter. Threat modeling refers to evaluating the assets and data flows of a system for potential security issues and determining the appropriate mitigations to prevent them. We want to think about how someone might use our systems and infrastructure, and both either intentionally or on accident, so that we can put the proper mechanisms in place to prevent misuse and keep our customers' data safe. We use it to consider the system from multiple angles, not just the intended workflow. We also realize, though, that not everyone is a threat modeling expert, nor should they be. Engineering teams are very busy innovating, and asking one engineer or a small team to create a threat model for every service or every new feature that they're building simply just doesn't scale. That's why we wanted a platform that would help automatically identify the applicable security threats to a system. We wanted to provide a starting point for engineers who may not be familiar with the traditional threat modeling methodologies. So automatically generating a starter threat model would drastically reduce noise for both software engineers and security engineers by generating a scoped-down list of applicable threats. By having this list automatically generated, our software engineers and security engineers can focus discussions on the more meaty security threats that need a human judgment call, such as business logic. So for example, take the threat elevation of privilege. This refers to a user gaining access to something they shouldn't have access to. While a proper login or authentication mechanism may be in place, a general user should never have access to system admin views, or one customer should never have access to another customer's data. Depending on the situation, it can be tricky to identify these types of issues with automation. That's why we prefer to have our high judgment engineers focus their time and energy on identifying these types of logic issues as opposed to the low-hanging fruit that can be detected by automation. So when it comes to security direction, the best guidance is actually guidance that no human needs to read and understand. Instead, it's organized and structured in a way that automation can understand it, apply it to what a human is building, and then tell humans what actually needs to be fixed. So building on that principle, we needed a scalable way to disperse that knowledge within the AWS organization, which included both product teams as well as our own security teams. So we had 4 main requirements for this system. The first was to empower builders to build secure products. This refers to the human engineers in our organization that are architecting and writing the code for our products. The second is be easily consumable for tools to automate threat model generation. This refers to our extended team of robots or automation scripts and tools that parse and input and act accordingly. The third requirement was that it had to easily integrate with our existing tools and processes, as well as future tools our team will build. Our existing tools included a workflow engine to guide product teams through the security review program, static code analyzers, dynamic scanners, and other security issue detection tools. And the last requirement for this platform was to have a low engineering and operational cost so that our team of security engineers could focus on what they do best and author great content, as opposed to worrying about the operational heavy lifting of maintaining this tool. So given this need for knowledge distribution at scale, we started evaluating the options. Luckily, we didn't have to look too far for an infrastructure that met our goals to keep engineering and operational costs low. We used AWS services to build an internal knowledge management platform to define the best practices needed to uphold our high security bar. This platform empowers the AWS organization with the knowledge needed to build secure products and protect customer data. It's available for Amazon employees to read and reference internally, empowering us to build secure solutions. And the guidance is also integrated into our existing workflow tooling for security reviews so that we don't have to wait on engineers to go directly to the tool, but rather the content is coming to them as part of security reviews within our organization. So just like in our design review program, threat modeling is also the heart of this tool. The platform itself is simple so that we can focus our efforts on the most important piece, which is the content. Content is structured in terms of threats and mitigations, or more simply put, potential problems and how to fix them. The platform was designed in a way where a human user, or in the future, an automated system, can tell it what they're building, and the system will display applicable threats to the product being built, as well as specific implementation guidance on how to prevent them from happening. So we have two levels of guidance here in this tool: recommendations and implementations. A recommendation, it refers to a more general guideline to prevent a security threat to a system. It's similar to security development best practices commonly known across the industry. So these don't change very frequently because they're security fundamentals. An implementation refers to the technical guidance that is technology specific or AWS service specific to counter against threats in our environment. We have several hundred active recommendations and implementations in use today. In the past year, our number of implementations added and updated has actually increased approximately 58% year over year. And that's because our team of security engineers is continuously updating this guidance as new implementations become available. We also peer review the content internally so that at least 2 engineers have reviewed it before it becomes available to all employees within the company. We collect feedback from product teams on the content that they would like to see added based on what they're building. We then track and prioritize this content in our backlog and then work with teams to really understand what they're trying to build for customers so that we can provide them with the right security guidance and the right direction to create a secure customer experience. So during our security reviews, we see a lot of common patterns on what's being built. So having this platform allows our team to centralize knowledge in one place so that even though guidance may apply at one review at a given time, it can be applied to future reviews as well. Based on these guidelines, we threat model and dive deep on secure implementations to harden our services for our customers. So here's a sample user interface of the tool. This particular page is the knowledge map, and it's what it sounds like. It maps all of the knowledge and content within this platform. All of the guidance for easy tracking is mapped to a phase of the security development lifecycle, or SDL. While this screenshot and the SDL show a more waterfall approach, the actual guidance also remains relevant for our teams following Agile. In the screenshot here, I clicked on the Building Secure Code option. So the first recommendation is perform output encoding before changing data context. Clicking on the recommendation expands it to show related implementations, which are the technical guidelines to actually complete the recommendation. So here's a sample recommendation from our platform. The recommendation is an action. So in this case, perform output encoding before changing data context. The first piece of content here is the threat, which is the why behind the recommendation. It shows the purpose of the recommendation and why it's recommended and why it's important for our engineers to follow this recommendation. So the threat in this case is that the threat here is cross-site scripting, in which a malicious user inserts scripts into web requests in an effort to exploit web application vulnerabilities. And this is what shows up in our generated threat models and really drives the security discussion between the AppSec team and our product teams. The threat is what we want to avoid because it can lead to information disclosure of critical customer data. So our design reviews focus on how we can mitigate against this attack from happening. And the rest of the article describes how to do that at a high level. To get into more details, we have implementations. So here's a specific implementation for the previous recommendation of having output encoding. Note the content hierarchy at the top. It shows the parent recommendation as well as the parent SDL phase that this implementation is tied to. The associated threat here also shows up, which is what appears in our threat model. And then the article goes into specific implementation guidance and rationale behind the implementation, as well as potential code samples or configuration examples on what developers need to do to build a secure product. This is the second part of the implementations. So implementations also have exit criteria and verification steps that can help development teams and security engineers assess when an implementation is complete. The verification step can be completed by humans or by automation. Internally, we have several partner teams that are building automated checks to find security issues in our products before they launch. So these automated checks actually map back to an implementation so that we can see which checks have automated coverage and do not need human intervention. So this lets our engineers focus more on the meaty security issues like application logic or validating correct security functionality on behalf of our customers. Each article also has tags to classify the content, usually related to the service or the technology that they are referencing. We'll come back to tagging in a bit. Building on AWS was a great way for us to dog food our own services. So let's take a quick look at the back end of this system. So the design is pretty simple as per our original requirements. When a user accesses the system, they first hit Amazon API Gateway. Amazon API Gateway handles the incoming requests and then calls a Lambda function based on the request. AWS Lambda then stores the business logic and then gets data from Amazon RDS based on what the request is. Amazon RDS is our relational database service, and that stores all of the content, like what we saw earlier, the recommendations, the implementations, tags, as well as the mapping between all of them. We also have an Amazon S3 bucket that stores static assets like the front-end code, which is used to render the UI of the tool. So using API Gateway and Lambda does a lot of the heavy lifting for us, such as load balancing. By using API Gateway, we don't have to run our own API stack or do horizontal scaling. Authentication also ties in more easily with Amazon API Gateway. We chose to use Lambda because we could configure it such that we don't have to run our own EC2 instances or patch them. This significantly reduces the operational overhead, for example, managing servers and auto-scaling groups. One of Amazon's leadership principles is invent and simplify. So by simplifying the architecture and reducing operational overhead, our security team can focus on what they do best, which is write great recommendations and implementations that will enable AWS to build secure products for our customers. So here are some of the APIs that we have in the system. They either take input of tags or a unique ID to a recommendation or implementation and return recommendations and or implementations. The last API here, return threats list, is what's actually used to generate starter threat models, and we'll cover that in a little bit. The APIs can also be called by our partner teams that are building automated checks against the implementations to get the latest list of recommendations and implementations to know what to build automation for. All of these APIs return output formatted as JSON, and then the JSON is then parsed by our workflow tool to create the baseline threat model specific to that service. Articles are assigned tags to assist with search and generating applicable threats. So remember we saw in the implementation, the last part was the actual tags that show the specific technologies or services that the implementation is about. So for example, other tags could include things like compute, storage, or API to help better scope down what the applicable threats are. Sometimes we have threats that apply to all or most services. For that, we have a special tag called core applied to those articles. The threat model generation engine then pulls in these threats by default for all threat models. This makes it really easy to manage and update. Say a new threat or issue is discovered in the industry tomorrow. We can simply add a new article or update an existing article with the core tag to add it to make sure that it gets added to all future security design reviews as a potential threat. For the AWS AppSec team, threat modeling is our bread and butter. We realize that not everyone is a threat modeling expert or a security expert, nor should they be. Engineering teams are busy innovating, and asking one engineer or a small team to create a threat model for every new service or every new feature that they build simply does not scale. That's why we built a knowledge base that could help engineers automatically identify the applicable security threats to a system. This platform and the content serve as a starting point for engineers who may not be familiar with more traditional threat modeling methodologies. So automatically generating a starter threat model drastically reduces noise for both software engineers as well as security engineers by generating a list of only the applicable threats to the system. By having this automatically generated, our engineers can focus discussions on the more meaty security issues that need human judgment, such as business logic or expected security functionality. So we automate generation of starter threat models to scale our program. Product teams know their product best, so we partner with them on threat modeling. Instead of going and saying, go build your own threat model and bring it back to us, we partner with product teams to enable them with the right tools to generate threat models. This includes a workflow engine with scoping questions to determine what is being built, and a knowledge base of secure implementation guidance, which we just saw. We simplify the process so that even newer software engineers can generate a good threat model with minimal effort. This gives security engineers a baseline of threats and mitigations to gauge the security posture, which also saves time by letting us know where to focus, and that in turn lets us scale better by taking a subset of the content and applying it to the design, as opposed to spitting out a laundry list of every single threat out there in the world today. But how is the threat model actually generated? So the AWS AppSec team uses an internally built workflow tool to manage and guide security design reviews for our services. This workflow tool presents design questions, like the one seen here, to services that are building new services or features. So each question and response pair is linked to a content tag within the security knowledge management tool. And this is where the tagging that we saw earlier comes in. So for example, if my service is using Amazon EC2, it would be associated with the tag compute. Or if my service is using Amazon 3, it might have the tag storage. So the responses to these questions are then used to generate the starter threat model by querying the knowledge platform to get the associated threats. So it uses, from the API list, it uses the API call return threats list, taking all of the relevant tags as input and spitting out the relevant threats to the system. So within the workflow tool, service teams and security engineers can view the relevant threats and links back to the knowledge platform and the associated implementations. Teams can then, within the workflow tool, actually triage the threats to say whether they've been mitigated or whether the remediation is in progress. Engineers can also mark threats as not applicable to their system, and we actually use this data of not applicable threats to fine-tune the guidance and fine-tune the tags to make it more applicable for future reviews. So let's take a look at how an example starter threat model gets generated. And for fun, we'll dog food our own service in this case, which is a security knowledge management tool. So our system uses AWS Lambda, Amazon API Gateway, Amazon RDS, and Amazon S3. The design question above is presented in the workflow tool. So now I've gone through and answered the services that my system is using. So here's a threat that's applicable to AWS Lambda if not configured correctly. And this is what shows up in the workflow tool as part of the security review process. The threat here is that hard-coded or insecurely stored secrets can be read by an attacker and can impact your service globally. The specific recommendation or action tied to that is use a trusted mechanism to store and deploy credentials during runtime. So this applies to the deployment phase of the software lifecycle. So again, we have guidance for every phase of the lifecycle. And this one is specific to runtime and runtime using Lambda. The threat model then also says the status of the threat as well as the relevant implementations for the system. So clicking the link for AWS Lambda takes users to the appropriate article on how to securely store and retrieve runtime secrets. And so this is the implementation here. Has more technical details, also has the threat, which is the why behind actually doing this implementation, as well as guidance on how to secure the system. So let's take a look at another sample threat. This one is applicable to Amazon RDS, also related to data handling. So the threat here is that a malicious actor gains access to your raw data storage and attempts to access the data stored at rest. And the recommendation here is pretty generic, which is encrypt data at rest, and that's applicable to many different services across AWS. But by having automation around this and having the principle of tagging actually only brings in the relevant implementations to the system. So rather than listing out all of the AWS services and how to do encryption on them, we only see Amazon RDS because that's what our system is using. So clicking that link takes users to the implementation guidance for encrypting data at rest using Amazon RDS. Often we do link to publicly available documentation or internal documentation that's prepared by the product teams. So we've covered a lot of areas of the security design review program here today. So let's do a quick recap. AWS holds a high security bar for our customers because we want to keep customer data and customer content safe. The AWS application security team partners with our product teams that are building new services and new features to build and design them in a secure way. Threat modeling helps us identify and mitigate issues before they are even introduced. And not everyone is a threat modeling expert, nor should they be. But to reduce the barrier of entry to create a good threat model and to help scale our security program, we automated generation of a starter threat model using an internally developed security knowledge platform. This reduces the operational overhead on our team, making it easy to maintain the infrastructure and lets our engineers focus on authoring good content that helps secure our infrastructure. And it also lets our engineers focus on partnering with product teams to launch secure products for our customers. Thank you.